Hey everyone, in this video we're going to be introducing internal combustion engines, and we're going to go over some of the goals of internal combustion engines, internal versus external combustion, and how to break an engine down by type. This video is part of a short video series on internal combustion engines. If you're fascinated by the science behind how vehicles and machinery operate, then this playlist is for you. In this series of videos, we'll explore the inner workings of internal combustion engines, how they work, and the principles that govern their operation. Whether you're a car enthusiast, a student engineering, or just someone interested in learning more about how the world works, this playlist is sure to satisfy your curiosity. So sit back and get to learn about the fascinating world of internal combustion engines. So the first question I want to pose to you is, what is an IC engine? So the first thing we need to define is IC, which stands for internal combustion. And an internal combustion engine can really be thought of a system that converts chemical energy to mechanical energy. And we do so, if you've studied thermodynamics or if you know a little bit about thermodynamics, you can essentially classify the IC engine as a heat engine. Now, essentially what we're creating is you are using heat to create mechanical energy, and we make this mechanical energy available. And we usually make it available in different systems. There's different ways of making it available, but most times an internal combustion engine makes its energy available through a rotating output shaft. And this rotating output shaft usually powers your wheels of your vehicles or your cars. Now, if we do a process diagram of what's happening, we have chemical energy in the form of fuel or a hydrocarbon usually, and some oxygen mixed together, and that creates a combustion that then converts our chemical energy into thermal energy. Once it's converted to thermal energy, what happens is during this process we have a really big increase in pressure and temperature, which turns it into mechanical energy. Now, just to look at a little bit of a diagram of how an engine works. Typically, most engines are going to be reciprocating, especially for IC engines. And you can see there's two valves drawn there. We'll talk about the valves later, but essentially we have a piston moving up and down inside a cylinder, and it translates to a rotational motion at the bottom on some sort of shaft. And we can use the principles of ideal gas as an approximation in order to figure out what happens to pressure and temperature within this combustion chamber shown above the piston. Now, the next thing we want to talk about is a little bit of how internal and external combustion differ. So a lot of combustion can happen internally or externally. And it's important to understand which systems have an external combustion system and which systems have an internal combustion. External combustion means that combustion happens outside and is not restricted by a chamber or volume. That's usually the case in steam engines. So in steam engines, we have an open container, and this open container creates some steam by heating up some water. Same thing with gas turbines. We also have an external type. Now, for internal combustion, reciprocating engines, as we saw right above, are internal combustion engines because there is an inner chamber where the combustion is happening. Another example of an internal combustion engine is a jet engine in an airplane, for example. A jet engine is another example of an internal combustion engine. However, we will not be covering that in much detail in this lecture series. Rocket engines are also a different type, and then firearms, finally, are another type of internal combustion engine. Believe it or not, the chamber is usually closed and the gunpowder explodes within the chamber. But we are not going to cover external or any other type of internal combustion engine outside of reciprocating engines, and we will briefly also discuss rotary engines. So there are many different types of internal combustion engines and many different ways in which we can classify them. It makes it a challenge to try and understand all the different ways in which the engines can be built, and all these different manufacturers have different ways of doing things. So the way we try to categorize everything is to classify by different styles of engines or types of engines. We do this by classifying by, for example, fuel types. So we have different fuels such as gasoline or diesel. We can also classify by size. So if we have big engines or small engines, we can differ the sizes. We also classify by number of cylinders. And another really important one is classifying by number of strokes in a cycle, which is usually 2 versus 4. Although there are some cycles with 5 strokes or 6 strokes, which are more specialty strokes. But we'll go all over this in future videos. This is just an introductory video to try and explain what is happening. Now, some of the terminology that we need to learn at this point to try and understand what's happening is the most basic terminology of the actual piston and cylinder assembly that an internal combustion engine would use in order to transfer this chemical energy to rotational energy, and first to a reciprocating motion that then moves it to a rotational motion that will change it to, that will be transferred to, for example, the wheels of your vehicle. So some of the things that we want to describe is the cylinder. So you see the cylinder is the actual cylinder, the whole thing. The piston is this piston, which is cylindrical in shape and moves up and down in our system. And we can classify a new name for the bore, which is essentially the diameter of that cylinder. The bore is the diameter of where the combustion can happen. Now I'm going to redraw this piston cylinder assembly to show how we can define the length in which the piston moves up and down. So if the piston is at the bottom at the start, it starts at what we call bottom dead center, and that is essentially the bottom of where the piston has range of motion. And this piston is going to move up and down inside the cylinder. It's going to move up to a point called top dead center. And so I'm going to write TDC is equal to top dead center. And we usually abbreviate this by BDC and TDC. So you'll see in future videos and in general, internal combustion engine engineers will usually talk about top dead center and BDC, bottom dead center as BDC and TDC. And the stroke is this distance that the piston travels from bottom to top. So it's a distance from BDC to TDC. Now, the next thing we want to talk about, and I'll draw this right now, is a little bit of the history of engines and trying to understand where they come from and where the need for internal combustion engines came from. So the first engines that we came up with were steam engines. And steam engines were very effective in doing a lot of transportation and used on mostly trains that would travel from really long distances. And steam engines work in the way that you heat up a system and you essentially create some steam and have a motion in a piston moving back and forth. Now, the first type of internal combustion engines were kind of like steam engines. They would have an opening and we would combust a fuel or some sort of fuel like coal or something like that in a chamber, and this chamber would move a piston back and forth from right to left, and this piston would then rotate a wheel which could be connected directly to a train, for example. So this was the type of first internal combustion engines, if you can think about it, but there was still an opening in that chamber that would be closed and opened over time. So the next question I have for you is, why did the IC engine get created, and why was there such a push for the internal combustion engine? And why didn't we continue with the steam engine? The steam engine seemed to work very well for transportation. So two of the main reasons, and you can pause here and try and think about it, but two of the main reasons are that in 1859, we discovered crude oil. And as soon as we discovered crude oil, we were able to refine the crude oil into different fuels that became very predictable in their combustion. One of the big problems of combusting with coal or combusting in different ways before that was that we didn't really have a consistent combustion that could happen at a very fast pace within a relatively small chamber. And this meant that we couldn't really do that for a vehicle that was small. Now, in 1888, the other invention that happened was that a person called Dunlop invented the pneumatic rubber tire. Up until then, vehicles were using wooden wheels, which were not good for high speed and long distance travel. So this pneumatic rubber tire allowed us to create personal vehicles that could go much higher speeds and therefore could use the IC engine as a way of transporting. Now, the reason why it's much better than steam is because if you put a steam engine, for example, on a car-sized vehicle, the problem was that it took a very long time to start because you had to heat up the water to a certain level, and it was also impractical because of the fact that it was so heavy due to having to carry a solid fuel, whereas the internal combustion engine made it a lot easier by being light and very quick to combust, even from low temperatures. And this was extremely helpful in making the car what it is today, and how much we use it today is thanks to this development of the tire. In the next video, we're going to take a deep dive into engine classifications and look at all the different ways in which we can classify the different types of engines that exist today. Thank you for watching. If you found this video helpful, please give it a thumbs up and subscribe to my channel for more content like this. And don't forget to hit the notification bell to stay updated to my latest videos. And really, your support helps me in creating informative and engaging content. So if you want to learn more about the topic or have suggestions for future videos, please leave a comment down below. And thanks again. We'll see you on the next one.